right, hello. I'm going to be helping answer this question about means and standard deviations. So the first thing is, let's read the question. A professor knows from past experience that the time for students to complete a quiz is normally distributed with a mean of 26 minutes and standard deviation of 3 minutes. Now the first question is, if the teacher allows 31 minutes for the quiz, what % of the students will not complete the quiz? The second question is, suppose that the teacher wants to allow sufficient time so that 95% of the students will complete the quiz in the allotted time. How much time should be allowed for the quiz? So first, let's underline some of the stuff in our very beginning question stem that will help us answer A and B. So the first thing, and I already had normally underlined, is that this is normally distributed. Our mean is 26 minutes and our standard deviation is 3 minutes. So one of the ways to kind of solve this word problem is to draw a normal distribution curve, especially because this is normally distributed. That usually helps me a lot, and forgive me, I'm no artist. Now the mean is 26 minutes. All right, so then if we go 3 standard deviations above and 3 standard deviations below, we will know what our values are. And I usually do this just to get a really good picture of what the numbers are at each standard deviation. So the standard deviation is 3 minutes. This will be 29 minutes because it's the mean plus the standard deviation, or mu plus sigma. 32 minutes, and again, forgive me, I'm no artist, and 35 minutes. Now we go below the mean. So it's 23 minutes, 20 minutes, and 17 minutes. All right, so that just gives us a general idea of how this sample, well, how much time it takes for the general student population to take this test. Now let's go to section A. If the teacher allows 31 minutes for the quiz, what % of students will not complete the quiz? All right, so 31 falls right here. So it's not on our beautiful normal distribution curves, which means we're probably going to have to look for a z-score. So on the next board, I have the z-score formula here. So z is equal to your number minus the mean divided by sigma, which is your standard deviation. So in this case, z is going to be equal to 31 minus 32, forgive me, 26. 26 all over 3. So now I'm going to pull up my handy dandy calculator to do that, at least the numerator. So it's 31 minus 26, which is 5 divided by 3. So we have a fraction. How is this going to be a z-score? Well, we're going to have to get to 2 decimal places because that's how you read this handy dandy z-score table. So 5 divided by 3 is 1.67, give or take. So we're going to go to our lovely z-score table. So we're going to go down. We're at 1.6 here. And then we go to 1.60, 0.61, 0.62, 0.63, 0.64, 0.65, 0.66, and lovely, 0.67, which is set to, our p-value then is set to 0.4, oh goodness, 525. All right, which means 45.25% of students are able to complete this test in 31 minutes. Now, how do I know this? Well, oh, forgive me, that's wrong as well. All right, so that's 45.25% of students fall to the right of the mean. Okay, but we want to know how many students did not complete the quiz. So that is everybody to the right of the mean. All right. So everyone to the right of the mean is 45.25% of students, and that is your answer, either 0.4525 or 45.25%, whichever one your teacher or professor prefers. Now, let's go to part B. Suppose that the teacher wants to allow sufficient time so that 95% of the students will complete the quiz in the allotted time. How much time should be allowed for the quiz? Round your answer to 2 decimal places. All right, so this, you'll need your handy dandy Z table again. And the best thing to do is to pretty much, it's 95%. So you want to find the Z score that correlates to 5%, or at least is the closest to 5%, which is 0.05. So we have right here, 0.0438, 478, 0.0517. So which one do you pick? Well, the one I usually pick is the one that is closest to 0.05. So let's say 0.05 minus 0.0478 is 0.022. So from here to 0.05 is 0.0022. We don't want this score. It's too far from 0.05. This is only 0.0017% or 0.0017 or 0.17% away from 0.05. So we're going to pick this one. And that Z score is 0.13. Okay, that is your Z score, 0.13. So we're going to put it into our little Z score formula here. So it's 0.13. And again, forgive me, I am no artist, is equal to, we don't know our X. We're going to have to do a little bit of algebra here. Minus 26. That's supposed to be a parentheses, all over 3. So now we're going to isolate for X. So you multiply by X on both sides. By 3 on both sides. So 0.13 times 3 is 0.39. I like to check on the calculator just to make sure, because in my career, I've made a few mistakes doing math, in school at least, where I've gotten points off for making a silly mistake. So I try to slow down by using a calculator. So that cancels out the 3 on this side. And then you get X minus 26. Now there's no absolute value or anything else like that because we know that this value is going to be greater than 26. So we're going to add 26 on both sides. And your answer is 26.39 minutes. And also you need to round to the second decimal place. It's done for you already. And I'm just going to box that. I'm going to box this. And this is your answer for A. And this is your answer for B. Alrighty, I hope that helps. I know it was quite a long answer, but it did involve quite a bit of drawing and referring to a table.